Hello viewers, in this session I shall introduce in a very basic manner programming with C++ using the relatively new IDE Code Blocks. I must excuse myself to say that my target audience for this session are computer science students and not professionals. I shall be explaining elementary ideas of installing code blocks in a computer and also attempting a simple starters program in C++. All through my career as a teacher and researcher, I found computers to be an excellent tool. Yet, it is not for the analytical or logical abilities of the device that I admire computers. I repeatedly remind my students and often myself that despite the claimed progress in artificial intelligence, the IQ of computers even today is a big zero. Then, what makes computers so useful? First of all, it is relatively reliable. It does not get a common cold that often. It is fast in performing actions given to it. A computer does not become lazy. Its ability to repeat actions without grumbling is a huge advantage. It is also accurate within reasonable limits. And of course, the computer is very obedient. It follows instructions given to it per se. If we are to make the best use of these qualities, the computer has to be programmed. It is the skill and the intelligence of the programmer which is eventually passed on to the computer. Programming languages are often classified as low level and high level. High level languages are those like Java or Python. A high level program looks similar to communication between us human beings. You must bear in mind that the processor of the computer cannot comprehend high level languages. The processor of the computer understands only ones and zeros. This combination of ones and zeros is known as machine language or low-level language. Specialized programs called compilers or interpreters are often employed to convert a high-level language to a low-level language before the instructions are executed by the processor of the computer. There are places where we use high-level language. In other places, we use low-level languages. I will explain this relative preference later. As for C++, I prefer to call it a middle-level language, with its features lying in between the two extremes. This classification is certainly subjective. And C++ is one language in which I enjoy writing programs. C++ is quick, versatile, and suited for scientific purposes. Besides, it is object-oriented in the sense we can create objects in C++. Objects in a program helps to break down complex situations. Now, when do we use high-level languages? When we have enough and more computer resource available, we are at the liberty to use a high-level language. I will explain what I mean by computer resource. Memory and processing speeds are the primary resources of a computer. So, when you are working on your own computer and the objectives of your program are moderate, it is perfectly alright to use a high-level language. Say for example Python. Python is very simple from the user point of view. At the same time, it drains the computer of its system resource. Sometimes you have situations where your system resources are limited. A typical case would be a high-end simulation experiment, or suppose you are handling some global network like a seismic recording system or a weather modeling algorithm. In such cases, there is a lot of data and processing to be done, and you may have to be stingy on the system resource. In such instances, it is better to use a low-level language, but pure machine language is difficult, rather cumbersome, and it is almost impossible to write programs directly in machine language. System resource is not eaten up by C++. This factor makes C++ the golden language in such situations. That is exactly why the most common use of C++ is the construction of operating systems. Whenever we try to write a program, we require a collection of virtual components. A file or project management system is required. We need a syntax editor into which the program is typed, we need a debugger to correct various errors. A compiler is required to generate the corresponding machine language. All these components bundled together is known as an IDE or an integrated development environment. I have been teaching C and C++ for some time, and in most classes I still find that the IDE being used is Turbo C++, created by Borland Software Corporation. I don't think professional programmers anywhere use Turbo C++ now, but students and educational institutions still use it. You can see here on the screen the traditional blue colored Turbo C++ IDE. If I am not wrong, the last update to Turbo C++ came out in 1996. There has been no release since then, and Turbo C++ has been discontinued. Also, Borland Software Corporation does not exist anymore. Yes, C++ fans have been keeping the IDE alive by creating its simulators. Yet, I feel that we have been for long riding a dead horse and should have migrated to different environments long back. Here I shall demonstrate how we can download and install Code Blocks on a system. Let us go to the codeblocks.org website. What you see here is the home page. The features of the IDE are listed here. Features of the compiler, the list of suitable compilers, features of the debugger, and the interface can be seen here. Let us go to this downloads link. Under normal circumstances, we will be requiring binary files, and therefore we will go to this particular page. Here we have the required files for Windows, Linux, and Mac operating systems. These files are for Windows operating system, these for Linux, and this one is for Mac. I am using a 64-bit processor computer with a Windows operating system, so I will be requiring one of these files. The first one is the regular download, but there is a catch here. This file does not have an associated compiler. When you are installing Code Blocks for the first time in your system and you require the compiler, then this fourth file will be suitable. This file along with the setup file also has the Ming W compiler. I will also explain what these other files are. This second file is the non-admin version. Suppose you are installing Code Blocks in your system, in your institution, where you do not have administrative permissions, then this file will be suitable for you. Suppose you want to download and just run Code Blocks straight away without doing an installation, then this third file is the suitable one. It is a no setup version. This fifth file is a no setup version which also has the compiler. Now, these last 5 files are equivalent to these first 5, with the only difference that these are ones for the slightly older computers with a 32-bit processor. So in my case, as I have already explained, I have a 64-bit processor computer and I require the compiler, so I will prefer this fourth download, mingw setup.exe. I can download the required file from ForceHub or from SourceForge. I have personally found ForceHub to be a little faster, so I will download it from this particular link. SourceForge is equally good, but let me click on this particular link, ForceHub. You can see here the download has started and it will take a very short while. This particular file which is being downloaded is an installer, which means once the download is complete, you can go to the downloads folder of your computer, just click on it, give the required permissions, and you will have the Code Blocks IDE installed on your computer. It is so simple a task. I will now explain how we can complete the installation of Code Blocks in a computer. I will go to the Downloads folder in the system. Now this is the installer which we downloaded right now, Code Blocks 2003, setup with the Ming file. Right click on it and you can see the options open and run as administrator. In some computers you may not see this one, you just have to click on open. Now I will run as administrator. Give the permissions. These are the terms which you have to agree with. Click on agree. All these selections will be made by default. You can see here the last selection. The last tick is the one for the Ming W compiler suite. This is also ticked by default. If it isn't, you have to tick it. Continue with the process. You can see that the destination folder for installation of Code Blocks is in program files. Give install. Now you see in this system I have already installed Code Blocks, and therefore I am getting the message the target directory does already exist. If you are doing this installation process from the installer for the first time in your computer, you will not be getting this message. The installation will progress, and all you have to do will be to click on the finish button at the end. But in my case, since I have already installed Code Blocks on my system, I am getting this message that it is already there. In this case, I will be exiting from the installation process by clicking this no. And now I will go to the desktop of this computer. Now, as I have already told you, this is the Code Blocks shortcut. Right click on it and open the IDE. This is the environment. We have the menus on top. We have the management panel here, the start here panel here, and the logs here. Primarily you can see here 3 panels. Now here we are going to attempt the new program, a very simple program, and for that purpose you have to click on this link, create a new project. So I am clicking on create a new project, and we have a window here, new from template. Here in the left panel the projects is selected, leave it as such. In the right panel in categories you click on console application and click go. Now we have another pop-up showing this option. If I put a tick here and give next, this window, pop-up window, will not turn up next time, but I am not doing that. I am leaving things as such. I shall remove the tick and give the next button. Now you are provided with an option to make a selection between C and C++. If you want a C program, then you must go to the C, select the C option. Now we are going for C++, therefore you can go with this one and click next once more. Now again here we are to enter the project title, and also we have to give the location in which projects, Code Blocks projects are saved. Now here in this case we do not have a specific location. We have not created a specific location for Code Blocks projects, and I prefer that Code Blocks projects be saved on the desktop, and therefore I will take a moment off to go to the Code Blocks, go to the desktop and create a folder here for saving the Code Blocks projects. So I will create a new folder here for C++ projects, and now we will come back to the IDE, Code Blocks IDE, create a new project, select console application from projects, go we will click next here, select C++, and we will make the appropriate selection for the project folder. Now we have created a folder called C++ on the desktop. Now we have to direct the path to that particular folder. Therefore, I will click on this path selection box, click here, go to the desktop, then click on the folder which we created right now, C++, select folder. Okay. Now the path has turned up. It is C++ folder on desktop. That is where all our projects will be saved. Now I am doing my first project, so I will first program, so I will put it as P1. Now when I am typing this text here, project title name here, I request you to watch this particular box, the third box where the project file name is to be entered. I am going to type in the first box. You observe the third box. I am typing P1 and you can see here the project file name is being entered automatically. It is p1.cbp, and I am going to click next. Now once more we will have a pop-up with compiler specified. It is GNU GCC compiler. That is because we had downloaded it and made it the default compiler. This create debug configuration, create release configurations must be selected and click finish. Now we have created the project P1. This is the management projects workspace. Here we have the project P1. Now in P1 we have sources. I am clicking on this plus and you can see here the main. I double click on it, I repeat, double click on it, and the program main.cpp is visible under the project P1. Now let me make it clear. What do we mean by projects? Project is equivalent to a file which we did in earlier IDEs like Borland. So there we used files. Here we are using a project known as P1. Now the project is open and this is the contents of the project of the program. This is the text which is there. We have not entered or typed in any syntax. Okay, the whole thing which you see here is known as the syntax. All the elements of this program together. Okay, that is known as the syntax. And you can see here each piece of the syntax. Each piece of the syntax is known as a token. This is one token, this is another token, this is another token. All these are tokens, and tokens add up to make the program or the syntax. And I will explain. Okay, before I explain, I will straight away run this program and demonstrate what the output of this program is. I shall click on this. To run the program, I shall click on this build. Now the build is equivalent to what we did, the compilation which we did earlier in other IDEs like Borland. So we will click on the build. You can watch the logs here. I am going to build. It is the yellow wheel. I will build, and you can see here a message is coming up. If it is blue, it means everything is okay. You can read this contents. It is 0 errors, 0 warnings, and this is the compilation process. The compilation has successfully turned up, and here you can see the next green colored play button. It is the run button. After the compilation or the build, you can press on this thing, the run, and you can see here this is the result. That is the output window has come on, and in the output window you can see here it is being printed the hello world. Now this is the output of the program. Now I am closing this window and we will go to the main.cpp file and explain what this program is all about. Now the first line is known as a preprocessor directive, and how do we know that it is a preprocessor directive? It is this thing which marks a preprocessor directive, the hash symbol, and this directive asks the IDE to include a file called IOStream along with the contents of the program. Okay, this is the contents of the program, and along with that, this contents of IOStream is also included before the compilation or the build. Okay, and it is only after including contents of IOStream that the machine language file is built through the compilation process. Now this one, so that is the preprocessor directive, and you can also see, those who are familiar with other IDEs, in some IDEs we use iostream.h. Here we are using only IOStream. Okay, then we have using namespace standard. This namespace has to be specified. Then we come to the main. It is called as an integer main, and this integer is the return type of a function. Okay, any function requires a return type. I will explain functions maybe sometime later. Now the main function we are classifying as being of integer return type, which is why here we are concluding the main function with a statement called return 0. Okay, here is the 0, which is this integer which was specified. So it was specified as integer and it is returning a 0. That of course has to be there to match the type with the return. And finally we come to this actual action taking place. This is the cout statement, and the cout statement has the purpose of printing this thing, hello world, on the screen. Now this thing, the hello world, is given between two double quotes, and whatever is given between these two double quotes is known as a string. And what is special about strings, these strings are taken a piece and sent to the screen. So whatever is there between these double quotes, it is taken together and printed on the screen, and that thing which is appearing between the double quotes is known as a string. And that is how, and this cout statement, you can see it is the hello world is being output on the screen, and when we require the cout to work, you must give these two angle brackets. Okay, these are two angle brackets. These two angle brackets together is known as an insertion operator. It inserts something onto the screen. Okay, again we have an insertion operator here, and after that we have an end line, ENDL. That is also very important because this end line object is causing the cursor to move to a new line. Okay, and that we have already observed in the output. Now we will make a compilation. A compilation is not required because we have not made any changes. We will make a run, and you can see here the hello world is here, then there is a blank line, and then this information about the execution of the program. There is a space here between hello world and process returned. Okay, now what I am going to do is I am going to remove this ENDL statement also with the angle bracket. I am going to do a compilation and then run. Now this is the output which you observe, and you can find that that space between hello world and the process description has been erased. So that means it is the ENDL which caused a space after this hello world. So I hope you understand the significance of this endl statement. I will now take the program back to what it was originally, and we have the hello world. Now suppose I am typing another cout statement. I want to do something more. I will copy this and paste this here. I shall say I want my lunch. Okay, sorry, I want my lunch. Now just for the sake of explaining, I am clicking on this run. Okay, you will find that there is no change. It is the same as the previous one. Now that is because, I hope you understand, that is because after changing this program, I did not build the program. So it is the build statement which brings in a new program or brings in a change to the program. If you build a program and after that you change the program but you don't build it again, then the change will not be affected in the output. So my point is, you have to, whenever you make a change in the program, then you have to build the program, or the compilation must be performed. Now I am going to perform the compilation. Okay, again 0 errors, 0 warnings, and now I will run. Now you can see what is being printed. It is hello world, I want my lunch. Okay, now I can do something else. I will give another endl here, maybe once more. Okay, I will build once more, and then there are some errors, it seems. That is because this debug is there. If you get this error, all you have to do is change from this debug and click on this release, then that will be fine. Then click on the build. Okay, no, there is some other error. It seems. Yes, I'm sorry, the end line. Okay, this is I will leave it as such. Okay, I will build and run, and you will see what is the effect of these end lines which we gave here. You can see in the output there is some space now between hello world and I want my lunch. So I hope you have understood the purpose of this. The cout statement sends something to the screen. Okay, whatever you want to send to the screen, you use this cout statement. The end line creates new lines, or the cursor is sent to a new line using this endl statement. Okay, and then here we have the new statement which I had added, I want my lunch. Okay, so you can also observe that here every part of the syntax, that is every token, appears in a different color. Okay, the preprocessor directive appears in green. Okay, the data type integer appears in dark blue, a function appears in black maybe. Okay, and also numerics like 0 appear in pink color. Okay, the statement of terminator. Okay, all operators, not only this one, all operators. This is an operator. Okay, this is an operator. Okay, this bracket is an operator. This is the insertion operator. All those appear in red color. Okay, so red is the color for operators. And we have almost come to the end of what I tried to convey this with this first program. But still, now before I complete, let me make a few comments. You must have done some programming in the other IDEs like Borland or Turbo C++, and there you must have used getch or clrscr, that is the get character function or the clear screen function. You see, what does getch do? Getch is get character, and it makes the computer to wait after printing the output on screen till the keyboard, some character is pressed from the keyboard. That is the purpose of getch. Because if you don't get ch, you will not be able to observe the output. Why? Because the output will come on screen and then immediately go blank and disappear. Okay, so to hold the output on the screen, we use the getch function. Again, we have used a clrscr, which is a clear screen function. And what does the clear screen function do? The clear screen is intended to have a piece of output on the screen, okay, and only that program output must be there on the screen. All previous outputs must be removed from the output window. So we want the output of only that particular run of the program, okay, to be present on the screen, output screen, and it is for that purpose which we use clrscr. Now, functions like clrscr or as I said right now, getch, okay, such functions are not there for this Code Blocks IDE because they are not required. As simple as that. Okay, they are not required because this is a properly built IDE. The output window will not go blank. It stays there till you ask the window to go away. Now this is the output window. I can close this program output window by either clicking here, or you can see this is the icon for the output window on the taskbar. Okay, so I can close the window from here also, but now I will open it and close it from here. Now you can see the output window icon has disappeared from the taskbar. So a review once more of whatever I tried to convey with this session of this very simple program. This program, first of all, we didn't type in the program, it was there previously, okay. Then so it will be there when you are attempting your first program by entering or calling a new program. First part, the preprocessor directive, of course IOStream has to be there, not iostream.h. Then a namespace is required. Then the main must be there, and everything you must stay within the main and do. Of course, there are things which you do outside the main, which I will explain sometime later. Okay, and so elementary things you do by staying within the main. Okay, then to output something you use cout. Okay, maybe it is a bit beyond what a beginner knows right now, but this cout is an object. Okay, endl is an object, and all these are called stream objects. Maybe objects I will deal with later. So now that is not something which you must worry about right now. Cout is used to output something on screen. Then this hello world is a string. A string is output as such on screen, and it is a string because it has occurred between the double quotes. Okay, and here we have two strings, hello world and I want my lunch. Again, maybe before I quit, I will do something. I will split this. I will copy this program. I will split it into two. I want, okay, I will make it look like this. I want my lunch. Okay. Okay. I am removing this end line here, which means I have made two cout statements. Three actually. The first one is hello world, the second one is I want, and the third one is my lunch. I am going to build and compile. Okay, you can see the output is same, by which I mean it is I want my lunch, which means even though I typed I want and my lunch in two different statements, the output has come out on one single line. Once more, you can see here, I want and my lunch come out on the same line, because between these two there are no ENDL statements. So to make it on two different lines, if you want it to be so, I will put an ENDL here. Okay. Before I type ENDL, I must put in this insertion operator, compile and run. You can see now I want and my lunch are coming out on two separate lines. So that is the gist of it. The importance of ENDL, the importance of cout, what a string is, the importance of giving a type to this main function, okay, and the entire main function being in this block, that is the main function starts here and ends here. Okay, when you, that is the specialty of this particular IDE, you click here where the block is beginning, you will see that the end of the block is also selected. Okay, so once more I click here, the other end is also selected. So this is what happens in the elementary C++ program. Okay. If you have any queries about this program or this session, you can contact me using the comment box of this video. Thank you.